All that's left to explain is the ignition sequence. Here's what to watch for. The sequence begins when the cryogenic arms, you saw them a moment ago, they'll swing back at -5 seconds. At 0, the DDO will call out allumage, which is ignition, and the main engine will light up. But we don't lift off, not quite yet. You got to count to 7 for 7 seconds. The computers are checking the performance in the main engine while it's burning on the ground. They check it twice to confirm it. Better to do this on the pad than once we're airborne in case they want to change anything or stop the procedures. If all is well, then and only then, the computers give the order to light the boosters. You listen to the DDO call out the final 10 seconds.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage EAP, décollage. Tous les paramètres à bord sont nominés.
Well, the cryogenic arms swung open right on time, triggering the ignition sequence. Did you count to 7? At 18:05 local, right on time, Ariane.5 began her mission, lifting off perfectly, thundering off the ground here in French Guiana, beginning mission number 6 for this year, carrying Eutelsat 21B and Star 1C3. She's rising into the night sky here above French Guiana. Fine shots, as always, beautifully impressive for the people on the observation sites and on the balconies here and around the base. Right now, Ariane weighs 774 tons, 774 tons at liftoff. She's burning 5 tons of fuel every second, 2.5 tons in each booster. Behind me, you can hear the DDO saying everything is all right. The main stage is also at the same time burning another 300 kilos of fuel per second. Ariane now following the program in the onboard computer, which is in the vehicle equipment bay in the second stage, which gives all the orders, including stage separations, which we'll soon begin to see. We're in the first of 4 flight phases. The first 3 are powered. The last is not. We'll describe each in turn and in detail so you can follow Ariane as she heads east across the Atlantic, where she'll separate the satellites after having passed over Africa. The flight phases. The first flight phase now, the main engine and the boosters. The boosters are going to burn another 10 seconds roughly, and you'll see them flame out on the screen. Then the main engine burns alone. Then the upper stage burns alone. That looks like the flame out of the boosters. And the DDO has called out the confirmation of that. You can see the 2 boosters on the upper part of the screen and the orange flames, the 2 boosters, and the white flame is the main engine, the composite of Ariane continuing to burn. The boosters will fall 500 kilometers from shore in a protected area, French Guiana in part chosen as a base for its opening on the water, posing no threat to local population. On the left of your screen, you see the cursor climbing up the line there. There are actually 2 lines. One is the real-time trajectory. The other is the optimal trajectory. And as long as one is superimposed on the other, we're right where we should be. Below that, 2 lines, A and V. A is altitude. We're over 100 kilometers. V is velocity. Our speed now approaching 230 kilometers per second. We need roughly around 9 kilometers per second to inject the satellites, so keep your eyes on the numbers there. Both the first and second stages using cryogenic propellant. Both have single engines. We're coming up on fairing jettison now. The DDO has called out confirmation of that. It's in 2 halves. There's one half that's out of camera range. The fairing protects the payload from shocks during Ariane's ascent through the atmosphere, and we don't need that protection anymore because we're out of the atmosphere, and we don't need the 500 kilos. The Vulcan engine roughly 50 centimeters square, I should say, weighing 250 kilos, generates enough power to launch Ariane 5, roughly equal to a pair of French high-speed trains, if you know the TGV system. Space Base here has become a world reference for professionalism. State-of-the-art facilities, the global space industry finding everything it needs here in French Guiana. Low population density, we mentioned, nearness to the equator, which allows a launch to benefit from the Earth's rotation to get to orbit more quickly. No hurricanes, earthquakes, even hills where radar can be installed to follow the launcher. Up next, a profile of Joanna Halimi on her job as launch site's operator.
My name is Joanna Halimi. I'm 30 years old and I have been with Arianespace for the past 5.5 years. I studied engineering at the Belfort Montbéliard Technology College and worked for Thales Alenia Space for 1.5 years. I wanted to work for Arianespace, so I sent off an application. I was called in for the interviews and was given the job. My work consists of 2 different activities, one which is year-round and one which is specific to the launch campaigns. My regular job is to be in charge of the energy operations and maintenance contracts for the Ariane, Soyuz and Vega launch complexes. I am the technical authority and must validate the operations and maintenance plans and on-site operations carried out by the energy teams. I also follow up any anomalies that may have occurred, and I check that all the operations have been carried out so that our installations are ready for the launch campaigns. During the launch campaign, I have some specific duties. When you begin at Arianespace, you get the training that will allow you to be put in charge of specialities such as pyrotechnics or upper section electrics or the command and control systems of Ariane and Soyuz, and also to become an assistant on all the launch sites. Today we are in the process of connecting the thermal batteries on the solid booster. During stage separation, the distancing rockets will ignite. The solid boosters will move away, and these batteries will provide the energy required to swivel the nozzle at the end of the thrust period and prevent a collision between the SRBs and the cryogenic main stage. After connecting the batteries at the final assembly building, we have to check that they have been properly connected from the CDL3. We check that the insulation and continuity of the equipment is correct. This job brings me into contact with many different people. I can work with French, German, or Swiss teams if I am working on Ariane, depending on what I'm doing. But when I'm working on the upper composite, I can meet people from all over the world. And obviously, when I'm at the Soyuz launch site, I work with Russian teams. Therefore, I am in this way absorbed into different cultures and learn many interesting technical facts, and it is also very enriching from a human point of view. What I love about my job is that it is varied, as I work on 3 different launch sites, Ariane, Vega and Soyuz, and it allows me to meet lots of different people from different countries. Working for Arianespace is above all exciting from a human point of view, and it also allows me to meet fascinating technical challenges.
While you were watching, that was the latest in our ongoing series of space profiles. While you were watching that, we were picked up by our first downrange tracking station over the border in Brazil, a place called Natal. The first station is here in Kourou. It's called Galileo, 15 kilometers behind Jupiter, where we are, atop the Montagne des Pères. Galileo sees Ariane for 9 minutes before the vehicle disappears over the horizon, and it's picked up by the Natal station. That's how the downrange system works. Brazil's Department of Defense runs the station for CNES in an agreement with ESA. All of Arianespace's trajectory has been designed, of course, to be followed from the ground, whether by land or by sea. The launcher is, as we speak, sending a radar and telemetry back to a network of stations, roughly 5 or 6 of them, and they keep constant watch on the health of her vital systems. Their antennas are picking up the signals and following the process, recording over 1,500 parameters, motor ignitions, shutdown, stage separations, much, much more. Some of this data is analyzed in real time. Other are examined after the flight to find out how the vehicle performed. You can imagine the enormous archives that this gives Arianespace with over 200 flights. and a wealth of technical data. DDO has just called out confirmation, extinction and separation of the lower stage. You can see how that looks up there, and ignition of the upper stage. We're into the second half of the mission, and with that milestone, Claude Berna has arrived. Claude is Vega Program Director for Ariane Space in French Guiana. Welcome.
Thank you very much for welcoming me. I'm very happy to join the party. Good evening, everyone.
Tell us right away, I got to put you to work. What's the role of the upper stage?
So the upper stage is the one which brings the satellites to the correct position on the transfer orbit just before the separation from the launcher.